Hello everyone! This week we're doing titration calculations. There are two methods to do this. Mr. Mitchell is going to do one, I'm going to do the other. So these two videos that you're having this week are for exactly the same thing. We want you to watch both and decide which method you find easier or understand better, and then just be consistent with that method. We're not going to be bothered which one you pick. Just pick the one that works best for you. So Mr. Mitchell is going to follow the method that is on the slides, and I'm going to follow the method of the triangles that we've been seeing up to now. So first of all, what is a titration? Why do we care about it? Well, the titration is a technique that we can use in the lab to find out the concentration of a solution that we don't know the concentration of. So it's actually super useful if you become a scientist or a chemist and you work in a lab. You'll find out that a ton of times your very precious lab mates will not label the solutions the way that they should. So you don't know the concentration that you have, and then you'll have to do a titration. So actually this happens a lot. Very useful. Okay, let's get started. So the first thing that we need for titration is having a balanced equation. And we need that because we're going to use the molar ratio the same way that we used it for the other calculations that we've been doing, because after all, we're still going to work with the triangles. So first we need the balanced equation. Second thing that you need to notice is that for titrations, we're always going to work with neutralization reactions. So we're always going to have a base, an acid, to give salt and water. So they're probably not going to give us the full equation in the question, but we can figure it out because they're going to give us the salt and the acid. So let's check if this equation is balanced. We have one sodium on the left, one sodium on the right, one oxygen on the left, one oxygen on the right, two hydrogens, one in sodium hydroxide, one in hydrochloric acid on the left, and two on the right, both on water, and one chlorine, one on the left and one on the right. So this equation is balanced, and that is the first thing that we need to look at. The second thing is that we actually need the equation. So this is the method that Mr. Mitchell is going to use. And he's going to use this equation C1 multiplied V1 divided by N1 equals C2 multiplied by V2 divided by N2. So Mr. Mitchell is going to explain this method. If you find it easier, that's absolutely fine. Please follow that method. I'm going to show you the other method in a minute, and you'll see that they both lead to exactly the same results. So in this method, you just need to input the values in the equation and you'll be fine. Let's work out the first example. So the first thing that we're going to do here is write the triangle that we want to use. So in this case is N, the number of moles, C, concentration, V, volume. So that's our triangle. I don't know if you have a system to remember it. I came up with the phrase no carrots or veggies. So no, N, number of moles, carrots, C, concentration, veggies, V, volume. It's not a very educational sentence because, you know, I want you to eat your veggies. But if it helps you remember the triangle, then I can survive you guys using it. So now that we have the triangle, let's see if the equation is balanced. So we have one sodium, one oxygen, two hydrogens, and one chlorine. This equation is balanced, so we're ready to go. Next thing that we're going to do is write down the information that we have from the question. So they're telling us, and I'm going to use a color system here, that we have 20 centimeters cubed and a concentration of 1 mole per liter of the base and 30 centimeters cubed of the acid. So let's write that down. So we have volume of the base, so I put VB, 20 centimeters cube. Concentration of the base, 1 mole per liter. So the first thing that we see straight away is that we have two different units here. So one is in centimeters cube, the other one is in liters. They need to be in the same unit. So we need to remember that centimeters cube is the same thing as milliliters. So to pass from milliliters to liters, we have to divide by 1000. So it's 0.02 liters. So we have the concentration, we have the volume, so we can calculate the number of moles. So the number of moles, oh, why did it change color? The number of moles of the base is concentration multiplied by volume, 0.02 multiplied by 1, 0.02 moles. Looking at the molar ratio, we can see that 1 mole of base is neutralized by 1 mole of acid. So it's 1 to 1, so it means that it's the same number of moles of the base than of the acid. So now we know that we have 0.02 moles of the hydrochloric acid. And we also, I put it in purple because that information comes from the base. But in the question we also know that the volume of the acid is 30 centimeters cube, which is 0.03 liters. So now we have the number of moles and the volume. Now we can calculate the concentration, which is what they're asking in the question. So the concentration of the acid is the number of moles divided by the volume. So 0.02 moles divided by 0.03 equals 0.666666. So I'm just going to round up to 0.67 moles per liter. So this is the method that I'm going to teach you. You see that we use the triangle. This is how Mr. Mitchell will do it, which is following the equation. And as you can see, it's exactly the same result that we get in the end. So it really doesn't matter which method you follow. Just remember that try to be consistent and just try to always do it in the same method. And practice makes perfect. And you can ask as many questions as you need because we're here to help. And we're actually very glad that you engage and that you ask questions. So please don't be embarrassed by it. Please, please, please ask us questions. Okay, so here's the first example. We don't have the equation written here, so that's the first thing that we need to do. If you don't know the formula for the salt or the acid or the base, you need to actually do SVSDF. So let's get started. I'm going to write the equation first. So it's telling us the sodium hydroxide, and it's giving us the formula very kindly, was neutralized by hydrochloric acid. So we know hydrochloric acid is the same as hydrogen chloride and is HCl. At this stage, I really hope that you know this by heart. And this is a neutralization reaction. So they're not telling us which base is made, but we know that from hydrochloric acid and sodium hydroxide, we have to get sodium chloride. So sodium chloride. Now you can do SVSDF for this if you want. I know the sodium chloride is NaCl. And I know that the second product that we get is water, because this is a neutralization reaction. So base and acid to give salt and water. And now let's see if it's balanced. So I'm not going to write all of the elements below the arrow. I'm just going to count and see if it's balanced. I don't mind that you don't write them either. I'm happy for you to just balance the equation as we go, the way that I'm going to do it, as long as you make sure that the equation is balanced at the end. So always make sure to count all of the elements. So the way that I do it is the same. It's literally just writing the elements down the arrow, but without actually writing them. I just do it in my head. So there's one sodium, one oxygen, two hydrogens, one in sodium hydroxide, one in hydrogen chloride, and two hydrogens, and one chlorine. So this equation is balanced. So now we know that the molar ratio is 1 to 1 to 1 to 1. So second thing that we're going to do, write our triangle. No carrots or veggies. And the third thing that we're going to do is write everything that we have from the question. So we know that the volume of the base is 10 centimeters cubed. So that is 0.01 liters. We also know that the concentration of the base is 2 moles per liter. So now we have the concentration and the volume. I'm going to calculate the number of moles of the base. So that is C times volume. So 0.01 times 2, that gives us 0.02 moles. Using the molar ratio, we know that 1 mole of the base is the same moles of the acid, so we know that the moles of the acid are going to be the same as the moles for the base, so 0.02 moles. And from the question, we know that we have a volume of the acid of 25 centimeters cubed, which is 0.025 liters. So now we can calculate the concentration, which is what they were asking for. So number of moles divided by volume, and this is 0.02 divided by 0.025. And this gives us, let me a second to put it in the calculation, in the calculator. 0.8 moles per liter. Yes. So easy peasy. 3 easy steps. 1, the balanced equation. 2, the triangle. 3, what we have from the question. And 4, what they're asking us. Let's see another example. So this is telling us that sodium hydroxide, if you don't know the formula, then please do SVSDF, was neutralized with sulfuric acid, and they're kind enough as there to give us the formula. Sulfuric acid and sodium hydroxide make the base sodium sulfate. I know this by heart, so I don't need to do SVSDF, but if you don't know this, please do it, because you can make a mistake with the number of sodiums. Also, it's very easy because it has to keep this structure, so it has to have 2 of the first to balance out the charges of the sulfate. So sodium is sodium plus, so it needs 2 to neutralize the 2 minus of the sulfate. Hydrogen is also plus. If it was calcium, calcium is 2 plus, so it balances on its own, so it would be like that. So if it was calcium hydroxide, calcium sulfate is CaSO4. But anyway, this is a quick way to do it. If you're not sure, do SVSDF, okay? And the other product is water. So we're going to balance this equation. We have 2 sodiums on the right, so we're going to need 2 sodiums on the left. Now we've also changed the oxygens and the hydrogens there. So now we have 2 oxygens, so we're going to need 2 oxygens there. And now we have 4 hydrogens, 2 from the sodium hydroxide, 2 from the sulfuric acid, and 2 hydrogens, 4 hydrogens in the water. So now this equation is balanced. So I do it like that because I do it in my head, but if you're not sure, then please write the elements below the arrow and balance them out as we did in class. So this equation is balanced. I'm going to write the triangle. No carrots or veggies. So that's my triangle. And now I'm going to write everything that I have from the question. So we have a volume of the base of 25 centimeters cubed, which is 0.25 liters. And we have a concentration of the base of 2 moles per liter. They are lacking the liters in the question. So now we can calculate, we have the volume, we have the concentration, we can calculate the number of moles. So number of moles of the base is concentration times volume. So 0.025 times 2, which is 0.05. And this is moles. Now, in the equation, we can see that the molar ratio is 2 of base and 1 of acid. So we have half of the acid as we have of the base. So number of moles of base is 1/2 of the moles of acid. So 0.025 moles of acid. I actually put this the other way around. So that would be moles of acid is 1/2 of the moles of base. So you see what I did there. I just applied the molar ratio. And we also knew from the equation, from the question, that we had a volume of acid of 28.7, that's a weird number, but that's how titration works, centimeters cubed, so 0.0287 liters. Remember to always pass centimeters cubed to liters, so we have the concentration in moles liter, because that's what they're asking. So now we have everything that we need to calculate the concentration, which is what they're asking for, as I said, in mole liters. So concentration equals number of moles divided by volume. So that is 0.025 moles divided by 0.0287 liters. And that is, give me a minute to put it through the calculator. 0.025 divided by 0.0287. 0.87 moles per liter. Yeah? Okay, so in this example, again, we start by writing the equation. We know that potassium hydroxide is KOH because they're telling us. They're also kind enough as to give us the hydrochloric acid, so HCl. And we know that the base and the acid gives us a salt, so it's going to be potassium chloride. I know that potassium chloride is KCl, but if you don't know, please make sure that you do SBSDF. And water, which I hope everyone knows at this stage. So let's make sure that the equation is balanced. We have one potassium on the left, one potassium on the right, one oxygen on the left, one oxygen on the right, two hydrogens on the left, two hydrogens on the right, and one chlorine on the left and one chlorine on the right. So this equation is balanced. Next thing, we write our triangle, no carrots or veggies. And now we can start writing what we have from the question. So we know that the volume of the base is 20 centimeters cubed, which is 0.02 liters, and it's asking us for the concentration in mole per liter. So we don't know the concentration of the base yet. It's also telling us that the volume of the acid is 42.6 centimeters cubed, which is 0.0426 liters, and the concentration of the acid is 0.5 mole per liter. With those two, volume and concentration, we can calculate the number of moles of the acid, which is 0.426 times 0.5, and this is 0.213 moles. We know with the molar ratio that 1 mole of base need 1 mole of acid. So the moles of acid is going to be the same as the mole of base, and it's going to be 0.0213 moles. So with this information now, we can calculate the concentration. So the concentration is number of moles divided by volume. So it's 0.0213 moles divided by 0.02, and that gives us 1.065 mole per liter. So there we have it. The next example is still the same. So first thing that we do is write the equation. Sodium hydroxide neutralized with sulfuric acid to give sodium sulfate and water. So this equation is not balanced. I'm going to balance. We need 2 sodiums from here, so I just put that 2 there. And now we've also changed the concentration of hydrogen, so I need to put another 2 there. Next thing that we do, no carrots or veggies, our triangle. And now we can write down what we have from the question. So it's telling us that the concentration of the base is 2 moles per liter. And it's asking us for the volume of the base. So we don't know this yet. It's also giving us that we have the volume of the acid which is 22 centimeters cube, or 2.022 liters, with a concentration of the acid of 0.1 mole per liter. It's also lacking the liter there. Those units are not correct. So with that, we can calculate using the triangle, because we have the concentration and the volume, the number of moles of acid. Moles. And we know that for one acid, we get double the base, because we're looking at the molar ratio. So the number of moles of the base is twice the moles of acid. So 0.0044 moles. With that information, now we can go back here and calculate the volume, which is the number of moles divided by the concentration. So 0.0044 moles divided by 2 moles per liter gives us 0.0022 liters. Remember that this is moles per liter. So this is in liters. Now, the question is asking us in centimeters cube. So we need to divide that. We need to multiply that by 1000, and we get that the volume of the base is 2.2 centimeters cube. It's very important that you look at what the question is asking. Sorry about that. And the final, is this the final example? I think it is the final example. So we write the equation as usual. Potassium hydroxide and phosphoric acid to give potassium. So potassium is +1, the same as hydrogen. So it's going to be K3PO4, but make sure that you do SVSDF if you're not sure. And let's balance this equation. So we have 3 potassiums, so we're going to have to change that. And now we've automatically changed the hydrogen. So now we have 3 and 3, 6. So we're going to have to put another 3 there. And now this equation is balanced. Now, no carrots or veggies. And now we write what we need, what we have from the equation. So the concentration of the base is 0.05 moles per liter. And we need to calculate the volume of the base. We also know that we have a volume of the acid of 17.1 centimeters cube, so 0.0171 liters, and a concentration of acid of 0.25 mole per liter. So now we calculate the number of moles. Number of moles of acid is concentration times volume. So 0.25 times 0.0171. And this is, let me put it in my calculator. 0.00428, rounding up. moles. And we know that 1 mole of acid needs 3 times the moles of base. So the moles of base are going to be 3 times the moles of acid. So that is 0.0128 moles. This information now can be used here to calculate the volume. So the volume is number of moles divided by concentration. So 0.0128 divided by 0.05. And this gives us 0.2565 liters. Again, they're asking us for the volume in centimeters cube. So centimeters cube is the same as milliliters. So we need to multiply by 1000. So 256.5 centimeters cube. So that is the result. These are all the examples that we have from this presentation. As we said, either follow Mr. Mitchell's method or this method, whatever is easier for you. Just stick with it and practice, and let us know if you have any doubts whatsoever. Have a very nice week.